MA087, Chapter 1.1. Okay, this is about whole numbers. Okay, first of all, let's learn about the order relation between two numbers. Okay, there's a definitions of numbers. Okay, natural numbers. Natural numbers are the numbers starting from 1. So 1, 2, 3, 4, 5, and so on. So you can put 3 dots after 5. This means the number keeps counting. So natural numbers are called also a counting numbers. Because when you count a number, you start from number 1, right? The counting numbers are called natural numbers. And the whole numbers include 0. So starting from 0 and natural numbers. So whole number starts from 0, including the natural numbers. So 0, 1, 2, 3, 4, 5, and so on. So we have two types of numbers so far, natural numbers and whole numbers. Okay, when we graph a whole number, so let's draw a number line. Okay, so number line starts from, the whole number starts from 0. So from 0, as you go to the right, the number increases. 3, 4, 5, 6, 7, and so on. So the number will go to the right infinitely. So we use the arrow. So arrow represent the number will be increasing and go to the right infinitely. So let's graph a whole number 3. Okay, 3. For example, if we want to graph a whole number 3, then what do we do? Then just put a dark circle on the number line 3. Put a dark circle. Okay, how about graphing the number 5? Then 5 is here, so put the dark circle on the number line on number 5. So this is how we graph a whole number. So on the number line, if the number is on the right of a number, then the number is greater. So the numbers get larger as you move from left to right. The numbers get smaller as you move from right to left. So as you go to the right, the number gets larger, and the number gets smaller as you go from right to the left. So there are two numbers, 3 and 5. 5 is greater than number 3 because 5 is located on the right of the number 3. So we can use an inequality symbol. Okay, number 5 is right of number 3, right? 5 is right of number 3, which means 5 is greater than number 3. So when we use a greater than, we use this symbol. Okay, so this means the number 5 is greater than what? The number 3, because 5 is located on the right of the number 3. Okay, how about the less than? Okay, let's compare these two numbers, 3 and 5. 3 is left of number 5. So when a number is located on the left side compared to another number on the right, then that number is smaller. So 3 is smaller than 5. Smaller than 5. Then we use this symbol. So this means 3 is smaller than 5. So on the number line, always the number on the right side is larger and the left side is smaller. And when a number is large, always the inequality symbol opens towards the larger number. So 5 is larger, so this symbol opens towards number 5. Okay, example 2. Okay, on the number line, what is 3 units to the right of 4? So let's graph a number line. So number line, okay, this number line is a whole number for the whole numbers. So starting from 0, as you go to the right, the number increases. So 1, 2, 3, 4, 5, 6, 7, 8, and so on. So in this case, okay, we want to find, okay, what is 3 units to the right of 4? So here it is. Let's graph the number 4 first. So here it is, number 4. So from this number 4, we're going to move 3 units to the right. 3 units to the right. That means 1 unit, 2 units, 3 units. So finally, we are on number line, on number 7 on this number line. So the result will be 7. So the answer will be 7 because 7 is 3 units to the right of number 4. So actually, this one is adding 2 numbers, right? So this one implies that 4 plus 3, right? 4 plus 3, which is equal to 7. So starting from number 4, you add 3 units to the right. When you add a number, you always move to the right, right? So this implies adding 2 numbers. Okay, the second definition is, okay, we're gonna write a whole number in words in standard form and in expanded form. Okay, first of all, we need to know the definition of place value charts. Okay, place value charts shows each digit has their unique number, unique name. Okay, as you move from the right, okay, the first digit is ones digit, and second from the right is tens digit, and third one is hundreds, and fourth one is thousands, and this digit is 10,000. So as you see this, there are three digits put together. So there's a group of 3 digits from the right. So every 3 digits from right, the place name is, the place value is, the first one is 1,000, and 3 more digits, then this is millions. 3 more digits to the left is the billions. So for each group, there is tens, hundreds, tens, hundreds, tens, hundreds, tens, hundreds, followed by the thousands, millions, and the billions. So for example, okay, here's the number 64276. So this number is written in standard form, and from the right, 3 digits from the right, we will put a comma. So each group of 3 digits from the right side is separated by a comma, and this group is called a period. So for this period, we just read thousands, millions, and billions. Okay, so let's read this number. 53167098842. So in this case, there are 3, 1, 2, 3. Actually, there are 4 periods, right? So this is not right. This should be 4 periods because we have 4 groups. From the right, 1, 2, 3, 4 groups, right? Okay, and that the third comma from the right is billions. The place value for this one is billions, right? Billions. And the second from the right, the second comma from the right is millions, and the first comma from the right is thousands. So this is how we can read. Okay, 5,316,000,000 and 709,842. That's it. Simple, right? So what we read is, read 3-digit number and followed by the place value for billions, millions, and thousands. Okay, then let's change these words. Write these words in standard form. Okay, 6 million. Okay, we have a million, the place value, 51,000, another place value, 874. So we can write it as this. So replace this million and thousand with commas. So 6 million, 51. Actually 51, we need a hundreds, place for the hundreds, right? So put 0 on this. So 6,051,000, comma, 874. Okay, so always be careful. If there's no 100, then put it 0. How about, what if we have something like this? 6,501,000. Okay, 501 is what? 501, right? So we can write it like this. How about 600,000? Instead of 51,000, how about 600,000? Then you can write 600,000 like this. Okay. Okay, the whole number 37,286 can be written in expanded form. Okay, how do you read this number? Okay, we can read that number as, okay, this comma is thousands, so 37,286, right? So 37,000, so 30, so the number 3 is the place value for this, the first, the number 3 is 10,000, right? 10,000. So actually this 3 indicates, okay, let me write it here again. So this 3 indicates 30,000, right? 30,000 plus. And this 7 is thousands, the place value is 1,000, so this will be 7,000. 7,000 plus, and the hundredths value is 2, so this will be 200, plus 8 is 10th digit, so there will be 80, and 1st digit is 6. Okay, so when you expand a whole number, it can be written as the sum of these numbers. So since there are 1, 2, 3, 4, 5 digits, so we should have 5 numbers added together. Okay, so the number 3 is 10,000, right? 10,000. So write down 3 and put all the zeros for the rest digits. And for this 7, put 7 and put 3 digits on the right, and so on. So this is the expanded form. Okay, so how would you write this number in words? Okay, first of all, okay, there are 2 commas, right? So the first comma from the right is 1,000, right? 1,000. And then the second from the right comma is millions, right? Millions. Millions. So we can write it as, okay, 82,593,071, right? So 82 first, so 82, and then followed by comma, which is millions, 82 million. And the second group is 593. This is 593, and comma is 1,000. And finally, 71. So 82,593,071. So that is how we read in Word. All right. Okay, now number 3, how to round a whole number to a given place value. Okay, let's round this number to the nearest 100. So when we round this one, okay, let me write the number 743. Okay, the nearest 100. 100 is what? 7, isn't it? The place value for the 100 is this. So we will decide whether we will leave this 100, the number 100, leave it as it is, or increase it by 1. So always check the number next to the, okay, when we round this number to the nearest 100, okay, 100 is the place value, so the place value for this 100 is 7. So we will decide whether we're going to increase this number by 1 or just leave it and put other digits from this number 7 to become zeros. Okay, so always check the digit on the right of this place value, 7. So let's check this number. And if this number is less than 5, then just leave it as it is. Leave this 7 as it is. And then put 4 and 3 into zeros. And if this value 4 is greater than or equal to 5, then we will increase this 7 by 1. So this 7 will become 8. And then 4 and 3, these digits will be replaced by zeros. Okay, so first consider the digit, the 100 place value, digit should be increased by 1 or not. And then always compare the next digit, the digit right of the place value. And then if it is less than 5, then just leave it and then place the digits of all the digits right of the place value equal to 0. Okay, so this one, in this case, since 4 is less than 5, we'll just leave 7 as it is. And then make 4 and 3 equal to 0. Okay, let's try a different example. Okay, round 46,738 to the nearest thousand. The given place value is 1000, because 1000 is this one. So we will decide whether we need to increase this 6 to 1 by 1 or just leave it. So we need to compare the next digit. Since 7 is greater than 5, greater than or equal to 5, right? We will increase this 6 by 1. So 6 will be increased by 1. So the answer for this one should be 47,000 and put other digits with zeros. Okay, round 29,873 to the nearest thousand. Okay, we should have 1000. So the place value 1000 is 9. So we will decide whether we need to include this 9 or not by comparing the next digit. So 8 is greater than or equal to 5. So we will increase this 9 plus 1. So it will be 10. So since 9 become 10, we need to increase this 3 by 1 again. So we carry 1 to this one, right? Become 3. So the answer will be 30,000. Can you see it? Because 9 became 10, right? 10. So 29 plus 10 is, so 9 becomes 10, right? 10. So 1 carry up, so 2 plus 1 is 3. Okay, around 435,278 to the nearest 10,000. So 10,000, the place value for this 10,000 is 3. Right, 3. So we want to check whether we will increase this 3 by 1 or just leave it by comparing the next digit 5. Okay, 5 is greater than or equal to 5. Okay, or equal to, so 5 is equal to 5, so this is true. So we will add this 3 by 1. So 3 becomes 4. So finally, this is equal to 4,400. That's it. So make this 3, increase this 3 by 1, and then put all the digits with zeros. To the right side of this 10,000. Okay, here is a pictograph. Okay, this picture contains dollar symbols. So beer has 1, 2, 3, 4, 5, 6. $6 symbols and Warren has $5 symbols. Okay, each symbol represents $10 billion. Then Bill has one more dollar symbol than Warren. So actually Bill has how many more dollars than Warren? Now, since $1 symbol represents $10 billion, Bill has $10 billion, $10 billion more than $10 billion more than what Warren has, right? How about, let's compare Bill and Larry. Okay, Bill has $6 symbols, Larry has $4 symbols, and Bill has 2 more dollar symbols. So Bill has $20 billion more than what Larry has. So by looking at the table, we can compare the data information. Okay, then let's try a different picture. So let's use this time pie chart, the circle graph. Okay, this circle graph shows average amount a household spend. So in this case, the larger piece indicates they spend more money on this category. So housing takes the largest area in this piece, in this circle graph. So this household spend mostly, more like $12,827 on this housing. And the second largest area is the transportation. So they spent the transportation was the second largest part they use annually, and so on. And the smallest piece shows they used the least amount in that area. So by looking at the circle graph, we can analyze the data. Okay, then let's try a different bar graph. Okay, this bar graph shows the expected population in the United States age 100 and over. So starting from 2020 and 2025, so every 5 years from 2020, the expected population is this one. So in 2020, it's a little over 200,000, and 2025 is between 400,000 and 200,000. So as time goes, the graph increases. Okay, first of all, it increases slowly, but later it increases rapidly, like this. So by looking at the bar graph, we can expect that the graph, as time passes, the number of people age 100 or over increasing very fast, steadily. Okay, then let's try a different example. Okay, the double bar graph is used for comparison. So in this case, there are 3 cars, and this double bar indicates the fuel efficiency. So in the case of Prius, the city, the mileage is 51 miles per gallon in city and 48 miles per gallon in highway. And for the Fusion, is 41 city and 36 miles per gallon in highway. And Honda is 40 and 43. As you see this, among these 3, 2 of them has, the mileage per gallon in city is higher than the mileage per gallon in highway. But only the Civic has more mileage in highway than the city mileage. So from this double bar graph, we can compare the difference between highway and city fuel efficiency in this case. So there are many types of graphs. So based on the graph, we can interpret the data and then analyze, and then we can explain how the data looks like. Okay, let's try a different type of graphs. Okay, this broken line graph shows that the effect of inflation on the value of $100,000 life insurance policy. So first of all, the life insurance policy was $100,000. Then every 5 years, this one is decreasing, like because of the inflation rate of 5%, let's say it's 5%, then this one decreased 5% like this. And then from this one, after 5 years, also 5% decreased, and the value also 5% decrease, and so on. So as time passes, the actual value of the previous previous amount is decreased 5%. So this is called broken line graph. So you have a data and then connect the data. Then once you connect it, the line is broken as you connect to the next point. And then finally we can see this one is keep decreasing, right? Keep decreasing. Okay, in this graph, let's connect these points. Okay, the blue is the population of Texas, and the other color is represent the population in California. So in 1900, okay, let's connect the points in Texas like this. Now this one is increasing, and then okay, let's put this one. So connect this California data. Now California is also increasing, but as you see this, the population in California is increasing rapidly compared to the increase of Texas. And then first of all, in 1900, there were more population in Texas because Texas is higher, and the population in California is lower than the population in Texas. But between 1925 and 1950, the population in California is now getting more than the population in Texas, right? So as you see this graph, so connect the points. So we have a broken line, and then this is the point where California population, it gets more. So it is important to understand the graph so that we can interpret and analyze and explain about the how the real situation is going about. All right, then let's try another one, the last one. Okay, this is a circle graph. So circle graph shows different areas for each piece, and the larger the area means the larger portion of the data. So in this case, what is the sport that has the least number of people? So the least number of people, so we need to find the least area, the piece that contains the least area, or the piece that contains the smallest number. So in this case, okay, the number of people who likes the sport golf is 20 people. So 20 is the least number, so the sport is golf, right? So the sport is the golf, and how many people? There are 20 people who likes this golf. All right, so this is all about section 1.1, and then okay, let's try the examples. The homework questions. Okay, please refer to a different video.